Here. Or has everyone responded?
Overseas. So been to Mexico but not Canada. So Mexico but not Canada would be in green 25%. Been to Canada but not Mexico. Canada but not Mexico is in orange. So awesome. Okay, let's get started. Standard 13 talks about a new way to calculate probabilities called conditional probabilities. Conditional probabilities describe the likelihood of one event given or assuming if we know that another event has already occurred. That's why it's called conditional. Conditional upon knowing that something has already happened, one event has already happened or occurred, what's the likelihood of another? Assuming something's already happened, what's the likelihood of another event? That type of description is called conditional probability. Notation for conditional probability is this right here. I say it out loud as the probability of A given that B has already happened. The probability of event A given that B has already happened. What comes after this vertical line is what we're already assuming to have transpired, what we already know has happened. So B has already happened. I already assume B. What's the likelihood that A also happens? That's what we're talking about for conditional probability. Probability of event A given B. I denote conditional probabilities with that vertical line through the middle. What comes after that vertical line is what we already know to be true. What's already happened, what we're already assuming. So to find the probability of A given B, I take the probability of A and B happening together. This is set notation for intersection or and, where they both happen simultaneously. The probability of A and B divided by the probability of B. Our focus today is to calculate some conditional probabilities using what's called a contingency table or a two-way table. And I took the poll results, people in this class who've been to either Canada or Mexico, and I put them up on this contingency table. In the two columns, I have the results for if you've been to Canada or not. This first column would be everyone that said, yes, I've been to Canada. The second column would be, no, I haven't been to Canada. Across the two rows, I have the results for having traveled to Mexico. And the top row is yes, I've been to Mexico. Bottom would be no, I haven't. So this 20% indicates what?
People have been both to Canada and Mexico.
Right. The other bottom corner, neither. Which one have these guys been to? Mexico, but not
Canada.
This would be Canada, but not Mexico. Okay. So some probabilities to review with here in this first column. These are not conditional probabilities yet. Let's just kind of review how to read a contingency table and calculate some probabilities. What's the proportion or probability of a student in this class having been to Mexico? If you've been to Mexico, you live in this top row. You could either have been to Mexico and also Canada, or just Mexico but not Canada. So I need to do what with these two? Add them together. 20% plus 25%. 45% total of people in this class have been to Mexico because they've either also been to Canada or just Mexico only and not Canada. It's the sum of these two outcomes. Everybody in the top row across that, yes, I've been to Mexico. Again, this first column is not conditional probabilities, it's just some review on two-way tables for us. Not Canada would be where? Canada, is it be the yes or the no column? No, so it'd be these two numbers. Those that have not been to Canada but Mexico, those that have been to neither. So 25% and 45%. That would be, what is that, 70%? 70% of us have not been to Canada. This means and. Mexico intersect Canada, or Mexico and Canada. What percent of us have been to Mexico and Canada? It's just one cell on the table, one number.
Yeah.
The 20, those have been to both. These guys right here, 20%. The last one, Mexico or Canada. Mexico Union Canada in set notation. Well, this means I'm going to add up everybody from Mexico plus everybody from Canada. So everybody who's been to Mexico, 20% and the 25%. That's the 45%. Plus everybody that's been to Canada. How many percent of us have been to Canada?
The 20.
The 20 and the 10. Those that live in this first column here to the left. 20% and 10%, or 30%. Anything wrong with that number so far? Is 75% the final answer? No, why not?
Because it's overlapping.
With what?
With both. Yes.
Yeah. Didn't I count the 20% that have been to both twice? I counted the 20% that have been to Mexico and the same 20% that have been to Canada because the 20% of us have been to both of the two countries. So I need to subtract off Mexico and Canada according to addition rule. I double count. So let's see here. This makes 75% minus 20% or 55%. Would it just be everyone except for the 45% that have been to neither? That's also a way to think about it. Those of you who've been to Mexico or Canada will just be everyone but those that haven't been to either. I'm basically adding up these three numbers, 25%, 20%, and 10% to make 55%. We're thinking about it as everyone except for those that have been to neither. Neither Mexico nor Canada. All right, let's do some conditional probabilities here in this next row. This next column here. Now that we've got some practice on reading a two-way table, let's use it to find some conditional probabilities. What does this notation mean?
Mexico given Canada.
So given that we know you've been to Canada, what's the chance you've also been to Mexico? If we're assuming you've been to Canada, what's the chance that you've been to Mexico? So this would be probability of Mexico, sorry, that backwards, Mexico and Canada divided by the probability of Canada. Okay, so we're assuming that they've been to Canada. Which column is those that have been to Canada? This column here, right?
Yeah.
So I'm going to figure out which column I have to live in. I assume that we've been to Canada. I have to know you've been to Canada. I'm conditional upon having been to Canada. So it would be this 30% of people that have been to Canada. That's going to go into the denominator of our probability ratio. Of the 30% that have been to Canada, what percent have also been to Mexico? 20. If it helps to cover up part of the table as you're putting these together, go ahead and do so. I'm assuming you've been to Canada. That's why this is conditional probability. So I can only look at this first column. 20%. Those that have been to Mexico and Canada is the 20% from that top number in the table. 0.2 divided by 0.3 is 0.667. There's a 2/3 chance that if you've been to Canada, you've also been to Mexico, for people here in class. If I know you've been to Canada, there's a 2/3 chance you've also been to Mexico. Next conditional probability. What does this mean? This notation, how would you describe that to someone? What's the chance that if you know you've been to Mexico, they've also been to Canada? I'm changing the assumption. Rather than knowing you've been to Canada, now we have to know you've been to Mexico. That's our base assumption in the conditional probability. Out of everyone that's been to Mexico, what's the chance that they've also been to Canada? Okay, so let's figure out where in the table we have to live. Those that have been to Mexico. Mexico is the rows. Those that have been to Mexico, is that the top row or the bottom row? So I have to kind of live in that top row. What's the total proportion of students that have been to Mexico? Let's start with that first. 45, because it's just these two numbers added together, right? Okay. I typically start by thinking, what do I have to divide by in these conditional probabilities? Out of that 45%, out of just looking at that top row, let's figure out what the rest of the probability ratio is. What percent has also been to Canada of those that have been to Mexico? The same 20%, right? Because these are the people that have been to both Mexico and Canada. Grab a calculator. What's that proportion work out to be? 0.2 divided by 0.45, 0.444. If you've been to Mexico, there's a 44.4% chance that you've also been to Canada for this distribution. Okay, a couple more conditional probabilities. I think if you understand the notation, it starts to be a little bit more apparent how you're going to use the table. So what does this mean?
Probability that you've been to Mexico, but you haven't been.
There we go. Okay, I like how you said it, this part here. If you've been to Mexico, assuming this is true, what's the chance that you have not been to Canada? The second in this conditional notation is what we're assuming to be true. If I know this, what's the likelihood that this is also true? What's the likelihood that you've not also been to Canada? Okay, so using conditional notation, out of all the proportion of students that have been to Mexico, what's the proportion that have not been to Canada? So not Canada, and Mexico. So I think we still have to live up in the same top row. Yes, I've been to Mexico is this top row. So what's the total proportion of people that have been to Mexico? I think it's the same 45% from the previous question. Now, if I have to live in that top row, I have to assume I've been to Mexico. So I only look at what's the value of those that have not been to Canada? 35%. This cell indicates, yes, I've been to Mexico, but no, I've not been to Canada. So that's the rest of the proportion for my probability. I think this is just the complement. This should be the other part that makes the full 100%. .25 divided by 0.45 is a total of 0.5556. These last two statements are just the opposite, so should be complementary out to 100%. Try the last one. So what do you have to assume to be true then, Bill? Okay, so figure out where that is in the table. If we assume you've not been to Canada, what's the chance that you also haven't been to Mexico?
I'm not confident.
Think about what do you have to know first. What are you assuming to be true of those two events? Not Canada or not Mexico? You have to know you've not been to Canada. Start with that. So not Canada would be 25 and 45?
Yeah.
So I have to live in this right hand column. So that would be, what is that, 70%?
Oh, yeah. No.
Out of the probability of not Canada, what would be not Mexico and not Canada up on top? Okay, let's try some notation. Not Canada is going to go on bottom. Find the total probability of people that have not been to Canada. Then on top, probability of not Canada and not Mexico. Where on the table is the proportion of people that have not been to either. I kind of build these conditional probabilities from the ground up. On bottom, I have to assume we're talking about of everyone that's not been to Canada first. Then of that group, which of them have also not been to Mexico? Build it from the ground up. So out of 0.7, you get 0.45.
Yeah, and then over there it's probably 0.25. You can add the probability.
Not Canada and Mexico. So what's the one number of people that have not been to Canada but have also been to Mexico? Okay, this is just the general, everybody who's not been to Canada. If you've not been to Canada, that means you could have also have been to Mexico too. So you could have been to Mexico and not Canada. Or been to Mexico. This is just the general probability of everyone that's not been to Canada. It can happen two different ways. Does that sound reasonable? Okay, let's start putting this final answer together. What do we know to be true? What do we have to assume for this conditional probability? Haven't been to Canada, so Canada would be the 2 columns. Which one are we talking about for everyone that's not been to Canada?
Right.
So you have to be only from this part of the table. Cover everything else up. What's the total proportion of people in class that have not been to Canada? 70%, because that means you could have been to Mexico but not Canada, or have been to neither Mexico nor Canada. So the total proportion of people that have not been to Canada, what I'm going to divide by in this ratio, is 25% and 45% put together, or 70%. Okay. Now looking only in this table, what's the proportion of students that have been to neither Canada nor Mexico, been to neither of them? 45%. Okay. Not Canada is the sum of these two. Not Canada and not Mexico is just this bottom cell in the right corner of the table, lower right corner of the table. 0.45 divided by 0.7, type that into your calculator, and I get a final answer of 64.29%. If you've not been to Canada, there's about a 64% chance that you've not been to Mexico either, for everyone here in class. How I interpret that given probability. Questions you guys have? Okay, let's start getting some more practice done then. Why don't you grab your laptops back out? There's a couple questions on Schoology I'd like you to start with.